Hey, everybody. I want to welcome you to our second edition of our Tales from Beyond the Geofence live stream. And and just to kind of get you situated on this, we're working on these live streams to try and sort of reach out and connect with people and provide people a little bit more information about how we're using drones in environmental sciences and the kind of challenges that we come across. And hopefully some of those interesting stories and tales will kind of percolate through and help kind of bring it home for you. Um, so today we're actually talking a little bit about some of the things that make it difficult sometimes to use drones, especially here in the U.S. and working with federal agencies. And I'm excited because we have some experts on the line here who have navigated these sort of thorny issues quite successfully, and have been able to actually achieve a lot of stuff despite some of these sort of ongoing challenges. So we're going to hear from some folks about how cybersecurity is a growing issue for drones and what that means for researchers, and a little bit about how different manufacturers are responding to this and the difficulties that researchers are facing as they try and comply with some of the policies that are resulting from new laws that are focused on some of these things. So that's what we're working on today, and so now we'll bring up our team and I'll introduce them to you. Um, so from our good friends at Atalo UAS, we have John Putney, and
Everybody.
John is uh, one of the founding partners of Atalo. He served for 10 years as a Marine officer and a naval aviator, including working in the UAV detachment as an officer in charge, a training publication author, design analyst, as well as a standardization and crew resource management instructor. So a lot of experience in working with some challenging logistical issues and having to work through problems when they arise. Um, and so as I said, he co-founded Atala UAS, which is a veteran-owned small business that provides superior training and consulting in the academic, commercial, and government UAS industry. So we'll be hearing from John, and along with John from Atalo, we're going to hear from Troy Walton. Troy is also an experienced aviator. He served for 8 years in the Marine Corps, both as an artillery officer and as an unmanned aircraft commander. Um, he's been across lots of different places, working in Asia for multiple military exercises, um, and uh, and he's excited, because he's working a lot more now with environmental applications and how UAVs can really change the game for those kinds of things. He has a Bachelor of Science degree in aerospace management. He's a private pilot with a background in operational planning, maintenance, and UAV flight instruction. So a lot of deep experience there. And then finally, we'll hear from Julian Dale from our shop here. And so Julian has been with our lab, the Duke Marine Robotics Remote Sensing Lab, since its inception. And he's our engineer. He fixes things and breaks things and fixes things again and again and again. But has a lot of experience in electrical and mechanical engineering, and has over 900 hours of flight time as a UAV pilot, managing a fleet of probably about 50 aircraft now here at our lab. So he's going to talk to us a little bit about the challenges of sort of platform compliance, how you can build or modify systems to be able to comply with some of these cybersecurity issues that we're dealing with. And so that's the team that's going to talk to you today, and hopefully some nuggets of wisdom will fall out, and that we'll be able to and help you think about ways to navigate some of these thorny issues if they arise. And the first thing we're going to do is we'll go to John, and hopefully John will be able to give us a good introduction to cybersecurity, some of the laws like the National Defense Authorization Act, which seems to be one of the things that's kind of teeing this up for us, and what kind of that means for UAS operators that are trying to work with federal agencies or perhaps with military contracts in these areas. And so, John, I'm just going to pass it over to you now.
Yeah, Dave, I appreciate the introduction and inviting us on to talk. I mean, we've been doing this with you guys for a while now, since we were in uniform. You talked about the military experience and the the drone squadron here, and that's when we first met the Mars Lab team, and we've been working together on some of these projects and problems. So I appreciate you inviting us on and having this conversation. What I can do is give a little bit of a background of like kind of how we got here, how we got started in some of this. Uh, like you mentioned, Dave, that we did a lot of this in uniform for small and medium tactical UAS, work with the FAA on airspace issues, integration issues in national airspace. And that was, at the time, even challenging to do it on the government side. And then we got out, started the company, and started to work with those same partners to improve their use of drones in all kind of different ways. Was kind of the idea of starting the company. So we got teamed up with the Mars Lab on these two projects, as well as other partners. It grew. The first one I've got listed there is Confirm, which I believe we pitched, I think, back in 2017 and started in the 2018 timeframe. That's coastal and fire management. So working with specifically Marine Corps installations to start drone programs and start tackling some of these problems they have there. It grew into the other project that's mentioned there, Ready, as with our partners at UNC and whatnot, and we expanded that to more installations besides just Camp Lejeune. Actually, all the installations on the Marine Corps installations on the East Coast. So that has grown due to some success, but also jumping through these challenges, which I'll talk about here in a second. But to kind of frame the problem, the DoD is a massive land manager, and as we worked with the natural resource folks and the folks on base and research teams, they do not have a lot of budget, equipment, or people to kind of tackle the size of typically, I would say, tackle the size of scope of the problems they're facing with monitoring the land and seeing what kind of impacts training and just natural impacts from storms and other things occur to their spaces. So with the Mars Lab, kind of pitched the idea, using UAS and their sensors as they became more and more mature. This is specifically commercial off-the-shelf systems. We can transfer those to those natural resource managers, teach them how to use them, and get them approved to use on base and make their lives easier to collect data. So data being the goal, getting the information, but there's a lot of steps to get there, especially with using small UAS, starting at that time frame and even including to today. It's not always a simple task. So the three main pillars were setting up a training course for those folks, developing a mission kit that's actual drones, whether it was rotor or fixed wing that we selected for different use cases, delivering that kit to them, and then working on their training programs and their protocols to standardize how they use them, especially in installations that have sensitive areas or restricted airspaces. They have a lot of requirements to do that, so we started tackling those problems with these projects. So ultimately, we did those things, but there were definitely challenges along the way. Here, let me go to the next slide there. So kind of what Dave introed with cybersecurity and NDAA, we had all the normal issues to get started. One, being a research team coming onto a base saying, hey, we want to show you and demonstrate how well these systems can collect data, how much cheaper it is, how it's safer than some traditional collection methods that they've been using with aviation platforms. So you have to go through all the normal approvals, getting with the range control, the base commander who technically owns the facility or legally is responsible for the facility, getting things like civil versus public determinations. That's important. From what rule set do you fall under? Is this Part 107 FAA regulated? Or is it DoD regulations? Are we doing a service for the DoD? So we kind of had to go through that process and get an official determination, so that way we could communicate that to the folks who we're working with. Airworthiness certificates for the small UAS. Some of this is about transferring it to government employees. So we had to make sure that the drones were going to be approved and usable once we gave them the kit. That was that's really the significant challenge, was transferring the technology. It was the first set of hoops got us in the door flying on base. The second set of hoops here with the cyber waivers and Ndaa compliance and Blue UAS was after we left, after we did the demonstration and gave them the gear, um, could they use it under their rule sets? And that's the whole public versus civil use. But we even went through hoops where the Mars Lab team got range safety officer qualified for Camp Lejeune. So we had all of those kind of things to set up, and we were, I would say, pretty well prepared for those and engaged with Camp Lejeune and the other facilities to start to get those processes started, to evaluate their SOPs and how we would comply and if there was any differences. And actually, right off the bat, we saw some impact where they updated some of their SOPs based on our initial conversations, which ultimately helped facilitate the use of these systems, kind of helping them inform different I believe it was geofences that they weren't fully aware of how the geofence could be used and applied. So we, through meetings and whatnot, kind of helped shape their thinking on that. And so those were really the first set of challenges, was getting our foot in the door. And if I remember correctly, Dave, the Mars Lab team had actually already done one small project down there. So there was some kind of, precedence to go off of to say, hey, this has been done before. We're going to do a little bit of a bigger manner this time, but also work through their protocols, not trying to kind of dodge, or get around what they have for safety. It's quite a significant set of things just to kind of even get in the door. So that was specifically for Marine Corps Base Camp Lejeune. There's a lot of training there. There's a lot of aviation there. There's restricted airspaces. So it was a big challenge, just even getting the normal approvals to get started. The second kind of side to this was in 2018. I put a couple bullet points on the slide here. So the NDAA, the National Defense Authorization Act, comes out every year for the fiscal budget. And essentially it's the House Armed Services Committee and the Senate Armed Services Committee, putting the defense budget forward. They vote on it, president signs it, but it also includes policies on what to buy and how to buy, and sometimes what not to buy. And 2018 was a pretty big year for essentially the covered telecom equipment is what it's called. So a lot of stuff that you may have heard in the news, some Chinese telecom companies were banned from government procurement and acquisitions. And it also included some small UAS and drone information in there. Although that kind of went relatively unnoticed, I would say by and large, we didn't see much of an impact from that until on that second bullet point. I don't know if you guys remember this, but I called it the Fitbit Fallout. But essentially, U.S. military members were wearing tracking devices, Fitbits, and athletic stuff, and they were exercising all over bases all over the world. Some of them forward deployed. Well, then it was leaked, this heat map of all that activity and locations. So in one leak, you can essentially see almost every facility on Earth where everybody was at. So that raised some serious eyebrows on what are we giving to our folks in the Defense Department? How is it being tracked? And at that time, the highest levels of the Defense Department kind of turned around on drones and said, what drones have we bought? Who's got them? Where are they? And ultimately, the answer came back, we don't know. That we've been letting units go out and buy commercial off-the-shelf stuff, including DJI Phantoms and everything. So Chinese-made equipment. And so they're in the middle of our project, the moratorium on drone procurement and use pretty much hit, and they sent out a memo that said, "Hey, no more using these on facilities or buying them." Shortly after that, the Cyber Waiver process, because the concern there was what information was available from these systems, So the cyber waiver process came out, and that's where we began to interface with the Office of Secretary of Defense, and they're submitting cyber waivers. We submitted the first one that year, later in 2018, to essentially continue our project. And we had to go through all the different elements of where is the data being collected, what kind of environment is it being collected from? Is it benign? Is it sensitive? Is it controlled? Is it a controlled environment? Um, to where is the data? How is it, moved in transit? How is it stored? How do we share it with our government partners, and where do we store it ourselves? So we kind of had to evaluate our entire system, document that, and present that to OSD for the first cyber waiver. And we did that, as well as some basic cybersecurity hygiene principles, access control, and ideas like that prevent leakage or spillage of maybe potentially sensitive government information. And we also set up a protocol with the partners at the base to evaluate, send them the information. They can look at it, what we have, and determine whether it's publicly releasable or not. So they had a say in that process as well. So that was kind of the initial, the first cyber waiver. And Troy, correct me if I'm wrong, but I believe we got that one renewed. They were only good for 6 months at a time, so you had to resubmit in that time every 6 months. And eventually OSD basically delegated that down to the Navy or service level. So then we started doing it with the Navy board. And we did that, I would say, for a year or maybe a year and a half. And then finally Blue UAS came out. So Blue UAS was a Defense Innovation Unit DIU initiative to kind of help solve this problem, because the cyber waiver process was so cumbersome. However, probably unintentionally, they created kind of a secondary problem with essentially highlighting only five approved vendors for the General Services Administration schedule, which is how the government can easily purchase things of this nature. So we kind of got pigeonholed. We built this mission kit, and then we got pigeonholed into, hey, it has to only be from these five vendors. And so they solved maybe kind of a resource issue, like, hey, we're not buying these drones from overseas, but they didn't solve really a security architecture problem, which is just because it's made in the US doesn't mean it's necessarily got cybersecurity applied. So Ndaa Compliance is the list of how to comply with that regulation. Blue UAS is which vendors they've selected to be on GSA so that government personnel can buy drones. So that was really how we walked through each of those significant kind of hurdles for our project team. And that third challenge, we had to go back and do a different source selection and make sure we're fielding drones from approved vendors, which was difficult at that point, so late in the project stages. Okay, last kind of thing I'll cover down here is just what I think are keys to success for going through this, and Troy and Julian will get more into some of the specifics, but I think looking back, establishing your team's competence early. We went in there, we had lots of meetings, understood what the regulations and references were. We provided a lot of detailed planning, spelled out responsibilities, contingencies, and different deconfliction measures. We worked on building the relationship with them. We had tons of meetings down at Lejeune. At that time, this was kind of pre-COVID era, so we had a lot of in-person meetings. But we were able to get their command to support, put their support down in writing for us to say, yes, we're willing to support this project. And I think we demonstrated a willingness to participate in their rules, and as I mentioned, kind of help write new ones as well, updating SOPs and whatnot. From an execution standpoint, we went out there and just executed professionally, safely, didn't push any boundaries, participated in all the rules, was in constant contact with range control and reporting, and used all the backup measures we could. And really, the last point there is just staying in touch. Troy and the secondary project, the expansion has been running with UNC, the Marine UAS Working Group, uh, which is kind of a monthly call in where they continue. Now that we've given them the kits and the gear and the training, they continue discussing the development of that training, their procedures, best practices, and they're now engaging their command elements, um, organically, whereas they hadn't before. So that's a little bit of, I guess, maybe the context to how we started getting involved in solving these problems and fielding drones on and working with federal or government and Department of Defense facilities. I'm sure I've left out a ton. That was kind of just a high level overview, but we definitely stepped through a lot of challenges with cybersecurity and NDAA as we went through there. So I'll turn it over to Troy now to clean up what I missed and cover down on maybe some more specifics of the current way of tackling these challenges.
Yeah, absolutely. Thanks, John. So, as he mentioned, we were able to get signatures, which is one of the biggest things that we had to do. And so, the basics for setting up a program, number one, there is probably one of the most important things, and that's to find an advocate. When we started the first project, we kind of had a bit of an inside track. We knew a lot of people at the installation. Our partner from UNC, Susan Cohen, was able to leverage some of her contacts for us to be able to get in and start talking and begin these conversations, because there was a lot of initial pushback, as John mentioned, from the inside, because when we hear the word drone, we think drones are just flying all over the place and no one's controlling them. At least that's what folks that are not in tune with what we are working on and what we are utilizing drones for think that happens. So kind of telling them what we do and how we do things, and then building our reputation up was the beginning of it. So now moving on, after the background of what John just gave, basically we have two different avenues to fly drones on DoD and government installations. The first John mentioned is Blue UAS. And then the second is that you can have a compliant drone that is not on this list, but then you have to go through a cyber waiver process. And I'm going to walk you through, we're extremely familiar with the Navy's portion. That's what we've done. I think we've received now 8 waivers or so that are good for 6 months at a time. We've got it for several different drones. But once they cracked down with the 2020 NDAA, it really kicked into Blue UAS is the easiest way to be able to fly a drone. It does not require a waiver. You purchase one of these 5 drones that were on Blue UAS 1.0 list. And I say 1.0 because I'll tell you about 2.0 here in just a few minutes. But the 1.0 list, those drones were not really designed for us as scientists. They were designed for the tactical folks, for the men and women in uniform. So we'll discuss a few of those drones here on the next slide, and I'll tell you a little bit more about why they're not really designed for us. But moving on down to the basics, the cyber waiver, just because you receive that still does not mean that you have permission to fly on the installation. That's why I go back and ties into bullet point number 1 of finding an advocate. You still have to receive permission from the base commander and then all the subordinate commands from there. So we're looking at basically range control and et cetera for getting permission to actually fly and to continue that. John, did we lose the slides there for a second? I can just keep talking if not. But we have our 4th bullet, which is the process to fly varies. So each service or each branch of the military, and then even other government organizations, such as the Army Corps of Engineers, they all have their own nuances and different ways and different avenues that you have to take in order to fly up your installation. The point here is that you have to allow time for processing of all this paperwork. There's signatures, routing, there's different waiver processes that they have to do. So there's questionnaires, and those vary based upon which service you're going to support. So they are very detailed. I had to reach out to the manufacturer several times to answer some of these questions. And that's what Julian, I assume, is going to talk about here a little bit too, some of the key weaves on how he's developing NDA compliant drones. But go to the next slide. DoD, their main concern is cybersecurity with all of these. So data leakage and information being kind of hacked out is obviously not good, especially when we're looking at DoD installations where there is a lot of sensitive sites located across the entirety, most bases. So the National Defense Authorization Act of 2020, I mentioned it specifically, Section 848, prohibits the operation or procurement of foreign-made unmanned aircraft systems. And the government still has unmanned aircraft systems, what it calls them. So you may have heard unoccupied, uncrewed, all mean the same thing. They're all drones, if you will. So the main components of a drone cannot be manufactured, and the target country here is really China. There's also foreign covered countries. So North Korea, Iran are also on the list. But if you don't know, DJI, I think the latest figure I saw, they own about 85% of the market because they're phenomenal drones. However, we can't use them aboard DoD installations. Batteries, carbon fiber props, etc., that is still allowed. So don't worry if, good luck trying to find a battery that doesn't come from China these days. That's very tough. And then the last bullet there, I'm going to go into the next slide talking about some of the different peculiarities of the different services. But over on the right, you can see the 5 drones that were approved on Blue UAS 1.0 list. So that was the first one that came out. There's Skydio X2, Vandals Robotics Vesper, Anafi USA, and then this Ion M440. As you can see in the 2 bottom pictures, as I already mentioned, they are designed for the tactical unit side. So designed to pop out of cave very quickly, be able to be launched within 20, 30 seconds. But us as environmental scientists, I'm not too concerned about being able to pull my drone out within 20 or 30 seconds and be airborne. I'd rather do things safely and get the full mission set up. So I'm going to take my time, and so these drones aren't really designed for mapping. So for example, we have some experience with Vandals Robotics Vesper. We're getting very much more used to it. It uses Q ground control as its software, but it was really designed for just live video feed. But we want to create maps with it in beautiful ortho mosaics that have high resolution, low ground sample distance, so I can really see details and track change over time. So in order to do that, it's taken a little bit of exploration, but we're moving in the right direction. We can go to the next slide with Blue UAS 2.0. So right now, they're introducing all of these aircraft incrementally. So they have announced the vendors that will be, or that are approved on the UAS 2.0 list. But right now, so far, there are only 2 more that have been approved. So right now we have 7 Blue UAS that are currently approved. The additional 2 off of that first list that I just showed you on the last slide, we have the SenseFly EB-TAC. And then just, I think last week, the FreeFly Alta X, which is a large heavy lift quadcopter, has now been approved as well. So this is good news for us as scientists. We're progressing in the right direction because these drones are more designed for what we utilize them for. So for example, we had a SenseFly EB Plus in the mission kit. Originally, we could no longer fly that on DoD installations because it's a Swiss company. However, it has Chinese chips inside of it. So now this SenseFly has come out with this EB-TAC and painted it a different color, and it's got this black and white camouflage, and they've changed some of the internal components. And this drone is designed for mapping, which is really at our core use cases for what we want. But then we also have in Talo with our partnership with UNC, we have the FreeFly Alta X, and we're utilizing that to fly an EPA payload on several different DoD installations. We've been to a couple Navy bases and then Army Corps installations as well. So those other 11 that you see down, those are the currently approved vendors. So their aircraft will be slowly being rolled out as they receive their approvals to proceed on. Okay, moving on to the next slide, we have the waiver process. So option one is to buy one of those 7 drones. You're able to go out and fly it as soon as you get permission via range control of the base commander. There is no waiver required. Our other avenue to fly drones on DoD installations is through this waiver process. So this applies for what's known as COTS drones, or commercial off the shelf, and you can buy these from various companies. So for the Navy, also the Marine Corps, since the Marine Corps falls under Department of the Navy, we have our guidance provided in this ComNav 4-inch 3710.9. And our project team, consisting of Atalo, Duke, and UNC with Susan Cohen, have spent, I can't tell you how many hours combing these documents. And of course, if you've never seen a government document, it has the document itself, which has information, but then half of it tells you to refer to all of these other 17 references that are listed. So we have been through a variety of documents trying to figure out this process, and we've finally got a grasp on it. So you have to have what's known as an IFC, an interim flight clearance, which is required for all non-Blue UAS drones. This was pretty easy before the 2020 NDA Act because a lot of them were already on there. But in order to get on the IFC, if you want to build your own drone, or you're purchasing from a rather small company, you have to go through NavAir. We were quoted at between, I think it was, if I recall correctly, $7,000 to $12,000 or so in order to get an approval, because they go through their own process. It involves the batteries, the drones, the whole system encompassing. And then once you have an IFC, then the final step is getting a flag officer, so a general or an admiral, or the SES equivalent, which is a high-ranking government official on the civilian sector, to endorse your package and put a signature on it. Now, moving on to the Army, it's essentially the same thing. That I have not seen the Army's questionnaire, but I imagine it's very similar. And then it all comes back to, again, you have to have an endorsement from a flag officer or the SES. And then finally, on the last slide for the waiver process, moving on to the Air Force, really just wanted to put these up here to show you where to get started at. For this one is Manual 11, the 502, TAC 29, all this. Same thing. We all have to come back to getting approval from a high-ranking official and having a very tight package and allowing plenty of time for that package to be routed. I think on average, just to give you a framework here, it took us 2 months on the shortest, and I think the longest was probably about 3 months from the time that we started the package of filling out the questionnaire until it was routed up. We got the general endorsement, then it goes up in front of the Naval Waiver Board, and they approve or deny. Luckily, they've approved it for us. Next one is the Army Corps. They have developed their own thing through the Engineering Research and Development Center, ERDEC, and they have the Small UAS Cyber Threat Management. So it's all of these are doable. You just have to be able to fill out the required paperwork, ensure you're dotting all your I's, crossing the T's. And then finally, to close it out for my portion, we're going to have the common practices by all. I've noticed this across doing research for all of the different branches, and including the Army Corps, is that the drones right now are not allowed to have an internet connection. There can be no Bluetooth. You have to have a dedicated ground control station. So now they're all kind of built in. We used to have a controller with your phone or a tablet on top. And even if the tablet never touched the internet, now it still all has to be kind of encompassed into its own little package, or a computer that never touches the Wi-Fi, which the last note there of air-gapped. That means that for firmware updates, you would have to download them from, assuming the internet, from a website or however the manufacturer does it. it off to a terminal drive CD, and then plug that into your ground control station or GCS. That again never touches a network, and they're pushed in that way. So that is the meaning of air gap. So it is a long process. It has taken us a long time to figure this out, but we are slowly kind of working our way in the correct direction, getting away from totally tactical, but we were just kind of modifying and adapting some of these tactical drones to meet our needs as environmental scientists. So I'd be happy to answer any questions once we are done with this, but for now, I'll go ahead and pass it over to Julian and let him tell you about his work.
Thank you, Troy. Well, I guess if everyone's heads aren't spinning enough already with just the process of obtaining the waiver, the next stage is actually trying to get something that's going to fly and collect your data. So I've been involved quite a bit with getting mostly photogrammetry-based platforms, multi-rotor platforms, and that through some of the Navy waiver process so that we can fly and collect morphometric data on that, on different animals. So I'm just going to present a little bit about some of the challenges and the processes and that, the rationale behind that, and some of the solutions, just to give you a little bit of an overview on how that looks. So I've got a presentation here, which hopefully we'll share. Assume everyone can see that okay. So for the waiver process, it was relatively straightforward from my respect anyway. We've simply had to supply details on the NDA compliant components that have gone into the aircraft, and then the end users have gone through their process of detailing down how and where they want to use the aircraft and things like that. So it seemed to be a relatively straightforward process. But essentially, there's three, well, I'm going to call it 3.5 different avenues that we've looked at. The first is an off-the-shelf Blue system, as Troy mentioned, the Blue 1.0 and 2.0, which is a little bit limiting in terms of the number of vendors. The next is an off-the-shelf NDA compliant aircraft, and then looking at custom building the payload to go underneath that so that we can actually accomplish the science mission. And the third is actually then going and building completely from scratch with all the components, airframe, and everything. My 2.5 is the in-betweeners. So there's a few cases here where we've got systems that kind of fall in between these last two that I'll quickly run over, and some of the solutions that we're looking at for that. So just to quickly go over again, the NDA components that Troy was and John were mentioning. Essentially, anything that's manufactured in a foreign country that's mostly relates to China for the most part for the components that we're looking at, and that's where 99% of the components in the drones now are manufactured. The critical components, ground control systems, and the network connectivity between them all. So just looking at what these actually mean in terms of the aircraft system, we're looking at the flight controller itself for controlling the aircraft, the radio for communication, either between the RC controller or some ground control station, any data transmission that's happening between that and any other outside systems. It covers the cameras and the gimbals that they're mounted on, the ground controllers, again, the radio controllers or the computer interface that you're using to control the aircraft, the software that's running, the network connectivity, and how that data is actually stored. So there's quite a lot of the critical components in there, as I say, which are all tend to be made in China that we have to try and source somewhere else. So I just did a quick bullet of some of the pros and cons of the different options here. So off the shelf, obviously, a lot of this is pre-approved, so there's no concerns over using and purchasing those systems. And often they don't require a continual review, exemption review. These systems, because they're being built by these manufacturers, well, obviously thoroughly tested, both the aircraft and the user interface that you're using to control them. And generally, they're relatively streamlined workflows and operation of the aircraft. So they're designed to, to unpack quick and get them in the air and do what you need to do with them. So the components are also generally tend to be, a much higher quality, professional military grade components because they're used in, harsh environments. And the last one here is the relatively short lead times, because most of the stuff is all approved and off the shelf, so you can get up and running pretty quickly with this equipment. The downside, however, is obviously the cost can be quite a bit higher when you're dealing with some of these, military grade systems. And as Troy pointed out, there's limited sensors that are, with under the blue system that are pre-approved, and a lot of those don't really cover the types of applications. The EB the SenseFly EB obviously is a great mapping platform, one that we've been using for a good number of years for mapping applications. At the moment, when it comes to the bigger multi-rotors for perhaps the photogrammetry side of things, the Ultra X is an amazing machine, but it'll also lift not one, not two, not three, but probably 4 small children off the ground. I think it's 35-pound payload capacity. So it's a very big machine, and a lot bigger than what we need, particularly if we're looking at photogrammetry working off small boats and things like that. So it's a little bit overkill for what we need. The problems because a lot of the parameters are kind of built and locked into these aircraft as well. If we need to modify any of these settings, and that often they're difficult to navigate, or those are locked in to the system. So if we need to change anything, for instance, operating off a moving vessel, or if we need to modify fail safes within the aircraft because of the type of environment that we're working in. So and Troy's touched on some of these these systems that are available now within the Blue UAS architecture. So the second is selecting an off-the-shelf compliant aircraft, and then building the payload to go underneath. So with this, we obviously have a compliant system that we know. Again, it should in theory be tested with a good user interface, good quality components within it, and then it gives us the option of custom building the scientific payload that we need underneath to give us the, to meet the objectives and the accuracy and the quality that we actually need for those scientific missions. The downside, we've obviously got to go through those approval processes, both for the aircraft and the payload. Some of those, well, I'd say some of them, almost all of the components are somewhat challenging to source. It's getting slowly better, but it's still a challenge to get those components. They also require a certain amount of mechanical and electrical integration with the aircraft system to actually get those to talk together, to be able to use perhaps the control interface for the aircraft to actually control the payload as well. So that takes a little bit of nutting out at times to get those to work together. Because they're not designed on the ground, from the ground up to work together. And there's also a certain amount of engineering required to go in to actually make those two systems together. The last is often these same components as essentially, although they're manufactured in the US, they're often, or as countries that are outside of China. When you actually look at some of the controllers in that here, if you see, for instance, one of the controllers here, $699 for a controller with HD video transmission. If we look for the compliance system, another $3,000 era for essentially the same controller, just with components that are built outside of China. So there's a significant cost difference just in, within individual components that go into actually converting these aircraft to make them compliant. And the third is what we've been doing quite a lot recently, is actually just building from scratch. The beauty with doing that is it gives you complete control over the whole system. So we can start selecting components, autopilots, and that we know that work in those environments and the temperatures, or working from moving vessels and things like that. Again, we build our custom payloads and that so that it meets those scientific requirements for the data that's coming out. And often it's better integrated into the payload's better integrated into the aircraft. So we've got more control over that side of things. And often the workflow is a little bit easier to deal with those systems. The downside, however, though, again, we've got to go through the same approval processes, difficult to source the components. The costs tend to be a little bit higher, and this is something that we're working with quite significantly now to try and figure out a mechanism to try and reduce some of those costs. But because essentially a lot of these are being bespoke built, the volumes are really small. We don't really have much purchasing power to bring some of those costs down, and there's quite a bit of engineering time that goes into each one of these builds. So each time we do that, or we have to change suppliers for certain components, then there's additional engineering work that goes in to actually, make all that stuff together and make it work. So this often leads to a slightly less refined and tested system, with not quite as many flight hours on it, and to put it through its rigors. And because if we're trying to make some of these different bits of equipment and that together that comply with the NDAA requirements, then often it's not quite as a seamless system, the end product. So often that requires a slightly higher level of pilot competency, trying to deal with the aircraft. It's not some of these systems and that are not quite as easy to use. So that makes it a little bit more of a challenge. So the in-betweeners, this is something, there's an example here. This is actually one of the free fly systems that we've been looking at using for, I'm just going to turn this volume down here so it doesn't drown everything out, which is a really nice, small, quick deployable quadcopter, capable of carrying a good payload. It'll work off a boat for the photogrammetry side of things. But when you look at the NDA compliance list here, you'll notice there's certain components within here that do not comply. Unfortunately, it's the actual remote controller and the video link side of things here is still made in China. So this is where we come into the in-betweeners, and we've been working with the likes of Free Fly to see whether or not we can actually use this aircraft system and swap out those, those radios, those bits that don't actually comply with something that will comply, and still give us the functionality, and be able to buy, a well-tested off-the-shelf aircraft that'll it's gone through all the rigors otherwise, and just deal with those individual components that we need to swap out to make that work. So here's an example of there's actually one sitting right behind me here. I don't know if you can see, but one that we just recently built for some photogrammetry work. And this is a complete mix of components from all over the place. The airframe is a carbon fiber monocoque frame that comes from China. We've got camera systems here, the Japanese, the Sony camera, laser altimeters from South Africa. We've got a remote controller that comes from the Czech Republic, video links from the States, and a gimbal from Poland. So it's a real hodge of a mix of different components that all have to mate together to get this all to work properly. And just to give you an idea, even using an airframe that's pre-built, we've had to go through, and there's 85 separate parts that had to be designed and manufactured just to get this system put together. So there's a considerable amount of time that goes into putting that all together. So just looking at some of the costs here, I just wanted to give a comparison when it comes to some of the photogrammetry systems, and this is something we're coming up against quite a bit with with folks trying to do morphometric measurements and getting US funding for their projects, even though the projects are scattered all over the world. Typically, a lot of people have been using either DJI Phantoms or the Inspires with a laser altimeter fitted, and they're used to paying somewhere in the region of $12,000 for an aircraft that it's a good solid platform. It flies very well. Flight time's a little bit on the short side, but the data quality that comes out of it is really good. And when we look at something else that we're having to marry up, either custom made or our in-betweeners here, you can see either something like a microcopter at around 22 grand, our custom aircraft at about 32, or something like the Free Fly Astro with a custom payload at around 39 by the time we go through and swap all those components and that out with the video transmitters. So there's there's a significant difference in cost there, and particularly within the science community, I think there's a real need to try and structure this in a way that we can bring those costs down and make it a little bit more affordable. So with that, I would welcome any questions there that we have for anyone online.
Well, thanks, Julian, and thanks, John and Troy. I think this is super helpful for people. I think I'll be the first person to say that as an academic researcher, I had really no understanding of why we had to jump through these kinds of hoops and what it all meant. We're flying around taking pictures of a beach or whales, and it's hard to understand why that would be super secret, right? And so this is super helpful to help people understand. And I think that's one of the first things that's has to come out of it, right? Is there has to be a better understanding of why we have cybersecurity issues. And I think the second part that I think is really nice about the stories that you guys have just spun is that a lot of people sort of see these things as real deal breakers and almost insurmountable things to deal with that may even cause people to give up. And I think the nice thing here is that it really provides a glimpse of how if you're a little bit tenacious, you can get through and do some really amazing things. And so maybe I got a question for you guys, and that's like if you have any bit of advice for someone who's kind of just starting to embark on a drone project that may intersect with a federal agency, whether in purchasing or whether working in federal lands, or maybe in particularly with the DoD, the Department of Defense. What kind of advice would you give people, as they start to contemplate trying to, get going on their work?
I think one of the biggest things probably to start with is to
just
check
some basic
the
stuff.
contract.
I think a little
Assuming
bit with
you're awarded,
what Troy and Julian
ensure
covered.
that it says in there,
there's more information
who you're supporting,
now.
where you're going to be
So
supporting,
obviously,
and then what the requirements are.
And then Troy. Who's going to go? We'll go John first. How's that?
Okay. Sorry, I'll be faster this time. Apologize for that, but I would say there's more information now is the good news. I think the processes are getting streamlined. But just doing some basic research into looking up what the regulations are, what's the current publication say, doing some specific research at the site that you want to execute at, and reaching out to others. We've gone through these processes, but there's other teams out there doing different types of research with different scenarios on federal property or lands, or different state and local. So I would say looking up those people and just reaching out to them and asking them how'd you do it, how'd you get involved, and how'd you solve these problems. So that'd be my 2 cents.
Thanks, John. Maybe we'll go to Troy now. Troy, what nuggets of wisdom do you have for people that are just starting to get going with this and may find it insurmountable?
Yeah, sorry about that. For some reason, John and I can't hear ourselves, so I'm sure he gave some great words of wisdom that were probably along the lines of what I was going to say. But basically, know where you're going to be flying, check the contract, ensure that you have to be, if they're mandating that you're NDA compliant, then know the list, ensure you have the latest list. That list is changing that we've seen. It was only the 5 drones for quite a while, but now we've recently had those additions that I mentioned of the EB-TAC and the Alta X. And then don't be scared to proceed on the waiver route as well. It is easier to not have to go through the waivers, obviously. It'll save you time. But you could be spending extra money for the Blue UAS drones that you don't necessarily need when you can get something cheaper that will better meet your requirements by either going to an expert like Julian who can build it, and then proceeding to get the waiver or even a COTS drone that is compliant. So check the list.
Awesome. That's great advice. And how about you, Julian? Anything that you want to add in there that might be helpful for people?
Yeah, I think probably just building a little bit of time. There's, a lot of these processes take, time to navigate, to get your head around. And then because in a lot of situations, there's nothing there's often not an off-the-shelf solution. So, these things take time to kind of plan out, to map out, to work through, your requirements for your science mission, and then try and piece together everything that's going to make it work. So, we would love to have a huge workshop and a team of minions out there, building frantically. But a lot of the time, that just doesn't happen. And unfortunately, for a lot of these small manufacturers and that as well, a lot of them are, relatively cottage industry. And for them, there's a cutoff point to where it becomes economical for them to go down the route of a custom build, especially if it's only going to be small numbers for them. So, there's a bit of navigating to happen to actually get that, to get that come to fruition and get something usable at the end. So, where possible, I'd recommend just leaving as much time as possible so you can kind of work through that. And as the John and Troy mentioned, reaching out, we've kind of navigated the waiver process and that with, quite a few of our colleagues. So, we've got examples of those questionnaire documents that we've supplied. So, we're happy to share those with you, so that you've got a template to work from and examples to work from. And then, hopefully that would kind of streamline that, or, at least know what to expect in that process.
Right. That's great. I guess maybe the last question is, I think a lot of the things that we've talked about have been related to timing, right? This change in regulation and the industry not necessarily being able to respond quickly. And certainly for us as researchers, we're even, more lagged in that sense. And so I'm wondering, like, how long do you think it's going to be before, we have the Blue UAS 3.0 platform for doing, a range of environmental missions? Is this something that's going to happen in the next month or year? What do you guys think about that? John, you want to go?
Sure. Yeah, I have some thoughts. I mean, I feel like the ability to comply and have secure operations for the types of work that we're talking about, I think the technology is already there. I think it's more of how do you get these things, easily approved, and how do you check that? How do you check that it's being used in the right way? And so that becomes more of a protocol bureaucracy type thing of why it's so difficult. I mean, I've seen this question a lot from the uniform side and some of the projects we work with there. It's like they're like, hey, this technology is great. It's very easy to use and get started. Why is it so hard to fly on base, even for someone that operates on base in the ranges? And so there's just an immature, airspace, just like what's going on with the FAA and the regulations there. So that how long that's taking to adopt these technologies is definitely slowing things down. I would say from a commercial technology standpoint, everything's there to have a secure drone. That's not a problem. And it's been done before, even on the with military applications. So hard to say a timeline for that. Because the government's not known for moving very quickly. But at least what we've seen in this project, we went from an all stop to now there are pathways forward to start fielding the technology. So I would anticipate it continuing to improve because advocacy is gaining in these places for the use of these systems for installation, natural resource, things like that within the DoD and other federal agencies. So I think the benefit is clear. And so advocacy is growing. So hopefully it speeds up. But that was kind of a non-answer to your question on timeline. But I would be optimistic that each year it hopefully is getting easier and easier for teams to do stuff like this.
All right. Well, that's good. It's good. I think leaving it on an optimistic note is probably a great thing. And so I want to I'll probably finish things up there. We're just about an hour now, and I want to thank John and Troy and Julian for providing us with their expertise in this area, and hopefully you guys will find this interesting and useful, especially those people who are thinking about engaging, in drone work in ways that might intersect with some of these cybersecurity issues, including the NDAA. So hopefully this will be a useful resource. For all the things that were mentioned, the links and things that were brought up, we're going to put them down here in the description for the video that's going to be on demand on YouTube, so people will be able to access those things. And so yeah, I just wanted to thank you guys again, and it's nice to be able to think about these things and help people work through them. And I'm hoping that that optimistic note is going to play through, and that soon we're going to have all sorts of amazing drone platforms on Blue UAS 3, 4, 5.0, depending on how much how optimistic we want to be. So with that, I'd like to thank everybody again, and say to everybody, thanks for listening and joining us. And remember, always fly safe. We'll see you soon.